All right, what I'm going to do is I'm going to take just a few of those perfect squares. So do you guys remember 1, 4, 9, 16? Do you have that on your paper? Yes. And we went all the way to what number? 225. I'm just going to take a few of them. I'll go with, let's go 49, 64, 81, 100. All right, I'll take a few of these here. And you can actually, if you could rewrite these underneath, because we're going to do stuff to it. Okay, this is part of the perfect squares list. So are there other perfect squares? Of course, we listed off more. And there are more than that even that we've listed. How many are there, you think? Infinite number, which is, again, baffling. But if you look back at your notes, do you guys remember under irrational numbers? Do you guys remember there are 3 types of irrational numbers? Non-repeating, non-terminating. Pi was an example. And what was that third category?
Non-perfect square roots.
Yeah, the square roots of non-perfect squares. And when you probably saw that at the beginning, when I first wrote that down, you're like, okay, square roots of non-perfect squares. Once we get done with this perfect square list, you're going to hopefully understand non-perfect squares better. Okay, so looking at this right here, what number times itself will get me 49? Yes, ma'am. 7. What number times itself will get me 64? 8. What number times itself will get me 100? Yes. 10. All right, good. What number times itself will get me 81? 9. Guys, okay with that? Okay. If that's the case, then I can do this very easily. What's the square root of 49? 7. What's the square root of 100? 10. The square root of 81? 9. The square root of 64? 8. How many of you can do all those perfect squares lists and find the square roots of all of them? What's the square root of 1? 1. What's the square root of 25?
5.
What's the square root of 49?
7.
What's the square root of 225?
15.
Okay. How many of you are good with the list that I gave you? You can find the square roots of them eventually, if not quickly.
So the square root is just what number times itself equals that number.
Perfect. That's it. Mm-hmm. So what number times itself will get me 100? 10. That's what we're saying. Wouldn't it be nice if all the problems are just, what's the square root of 16? 4. What's the square root of 100? 10. That's not what the homework's about. What about the square root of 20?
10. No, nothing.
So what number times itself will get me 20 is what I'm asking, right? 4.5. Is that exact or an estimate? Estimate. Okay. Let me think of it real quick. Shh. Error. Cannot find it. Okay. This is what happened. This number right here is a number I can find on a calculator, but I'm not allowing you to find it on your calculator. I want you to be able to do it up here and get very close to it. Not exact, but very close to it. Yes, ma'am.
For the answers, I don't know if you already did it. I probably wasn't looking. But do you write the number on top like a division problem, like the answer?
Let me show you how to write the answer. How about that? Okay, how many of you are saying to yourself, I'm not exactly sure, but I may have a guess? You're not exactly sure, but you have a guess. How many of you are like, I have no guess, I have no clue? Okay, it's hard. This is what I need to do. I'm thinking of my perfect squares list, and this is what I have to do, and this is what you're going to do in your homework. What perfect square is right before 20? Right before 20 on your list?
16.
Okay, 16. What perfect square is right after 20?
25.
Okay. And I wish they would have asked me the square root of 16, which would have been
4.
Or they would have asked me the square root of 25, that would have been. So on a number line, if I have 5 there and 4 there, the square root of 20, wouldn't it fall somewhere in between? But would it be right in the middle or closer to 4 or 5? Which one? Is it right in the middle? Closer to 4 or closer to 5? What do you think?
4.
Can someone explain why they think closer to 4? Because we haven't, we're estimating? Annie?
16 is 4 away from 20, and 25 is 5 away from 20, so 16 is 5 away.
Okay, how many of you are thinking this is 4 away, this is 5 away, just a little bit closer to the 16? Okay, on a number line, would you guys be okay with saying something like that? Like half is right here. Are you okay with that? 4.42 is my estimate. 4.42. Okay. So.
Do you want us to write?
No, you don't have to write that. That's just my estimate. Let's see if that is actually the case. All right, here's my calculator. And again, you're not going to be able to use it, but we're just using this right now in class to confirm. All right, the square root of, what was the number, 20? All right, so I put in 20. And then you see this little symbol right here on calculators. And when we write it down, it's called a radical sign. Radical, okay? Because it's that cool. Okay, click. I don't know what I said, but 4, it's actually 4.472135954999579.
Does it repeat or does it end?
What a great question. Who has an answer? Does it repeat?
No.
No, it doesn't repeat. Doesn't have a repeatable pattern. Does it end, though, is a good, tough question.
Yes.
Okay, this number right here has an ending. But the square root of 20, do you think it really ends there? No, does not end there. If I had a better calculator, it can give me more digits, and it eventually would end, but it's actually rounding it. So let me ask you this question if you remember anything from this morning. If a decimal number does not end and never repeats, what kind of number is it? Cole? Irrational. Irrational number. So going back, yes, Max?
But how would you know if that number, how would you know if it's ending or you just run out of space, if it actually ended or you just ran out of space?
Yeah, like, what if it really just ended there, right? How do you know if it ended there or if it actually kept going? And this is where we're going to get into our lesson here, wrong button, every square root of a non-perfect number. Are these perfect squares? Is this a perfect square? If you're getting the square root of a non-perfect square, it's always going to go forever and it's never going to repeat. You all automatically know that. You guys know that. If I ask a 5th grader, they're going to say, Mr. A, but it does end right there. And I'll say, nope, it will keep going on. So the square root of 20, 4.47, I think we said. 4.47, really close to 4.5. Do you guys see how it's closer to 4, though? A little bit leaning toward 4. You guys okay with that? So what do you have to do on your assignment? Okay, if I say find the square root of 20, do you know the exact value? No, this is what you put. It's in between 4 and 5. That's going to be one of your answers. It's in between 4 and 5, and we can see that here from that. And which one is it closer to? 4. So you put 4. That's what you're going to have to do. Guys, semi-okay with the process as in it makes some kind of sense, even though you might not know it? Okay, question. Yep.
Do you want us to write 4 and 5, or do you want us to write in between?
Sorry, what was the last part?
Do you want us to write 4 and 5, or in between 4 and 5?
You could write in between 4 and 5 or 4 and 5. We'll get what you're saying.
Will we ever have to figure out the square root of something without a calculator? Like not a non-perfect square root.
Will you ever have to find that out without a calculator? Yes. Actually, about 10 minutes.
Put an invisible watch. I want to.
Yeah, it's not working today. Okay, anyway, let's do another example. The square root of, I'm going to go with the square root of 80. Okay. Is 80 a perfect square? Is 80 a perfect square? No, it's not on my list. Which one is right after? 81. Which one is right before? Oh, I was going to write that. 64. Do I know what the square root of 64 is? It's 8. Do I know what the square root of 81 is? It's 9. Between what two integers is the square root of 80? 8 and 9, we would say. 8 and 9. That would be one of my answers. That's not too bad. And the second question, which one is it closest to? Chelsea? 9. How close do you think it is? Very close. Can someone give me an estimate for what do they think to the nearest tenth? So like your choices are this, 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9. Which one is it closest to? Or even 9 itself, technically. What do you think, Jack? 8.9. I'm going to say it's closest to 9.0. Like it's right there. It's right next to it. But don't take my word for it. I'm not going to switch to the screen, but Callie, you can confirm if I'm saying the right thing. So square root of 80. 8 point, oh, look at that. 8.944, blah, 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 blah. Does it end? That's a trick question, kind of. Does it end? Yes. On this screen it ends, but does it really end? No. Does it repeat? Look at how many 9s there are. 9, 4. Well, sorry, and I guess I'm asking these two. 8.94427, ready? 909999. 159.
No.
Okay, good. No pattern. And even if it has a pattern, if it's not in that repeating sequence, it is not a repeating decimal. So 8.9, I think you guys said, which is correct. I was off on 9.0. Great question. Next one. All right. The square root, we're going to do this next one. The square root of 77, the opposite of that value. And this is where you got to pay attention because it's not always what you intuitively think. Because it's a negative number. It's a little weird. Okay. The square root of 77, okay. Opposite or the negative square root of 77.
Wait, I have a question.
Yes, ma'am?
So wait, if you're finding the square root of something, could it also be like a negative? Because two negatives make positive?
See, and that's a good question. We're getting into imaginary numbers. I know. I thought all numbers were imaginary. If I had the square root of negative 77, we have a problem. But if I say the opposite of the square root of 77, you can almost think of it as what's the square root of 77? Negative version. Okay. What two perfect squares does 77 lie in between? What two consecutive perfect squares? Give me one before or after, Mandy. 64. Sounds familiar. One after it. 81.
Would it not be negative 64 and negative 81?
Yep. So again, we're talking about negative, so good. What's the negative version of the square root of 64? Negative 8. What's the negative version of the square root of 81? Negative 9. I want you to write the numbers in order. So would I say negative 8, and yeah, from least to greatest. Would I say negative 8, negative 9?
No.
Why not?
Because negative 9.
Further to the left. You would have to write your answer. I'm not going to mark it all off. I'll mark off a little point on it. Negative 9 and negative 8. Because isn't negative 9 on the number line, then negative 8? So this number has to fall between these two. Which one is it closest to? Negative 9. So these are your answers. So be careful with negatives. It's really just this little part right here. Gets flipped. How many of you see the value of knowing perfect squares? Like perfect squares helps me to do this. Okay, not everyone. How many of you, well, let me ask this question. When did you learn about perfect squares? Like when's the first time someone told you about a perfect square? When do you think?
When we were on I, because I wanted to take that
Oh, okay.
to see where we replaced, I asked you what square root was.
Okay. Okay, and I'm thinking like perfect squares like 64 and 81. That's right. 64 and 81.
I think most of us learned it today.
Okay, it's maybe just today you're like, this is the first day.
I learned about the numbers in like second or third grade, but I didn't know
Yep,
they
it
were
was second and third grade. Did you ever have to learn 8 times 8?
Yeah.
You know why? Because of that? Did you ever learn 9 times 9?
Yes.
12 times 12?
Yes.
If you had to learn that back in that, and I tutored kids, second grade, third grade, they're learning that. That's why. You had to learn that because it makes this easier. If you didn't know 64, you're like, I don't even know where 64 comes from, then that's harder. But you actually learned this a long time ago. Okay, any questions on this procedure right here?
I have a question.
Yes, ma'am?
What about if you magically didn't know multiplication problems?
Yep.
How would you find the square root?
You would make it very hard for yourself. In fact, that's why I'm not letting you use a calculator, because I want you to get it in your head first. Next year you use calculator.
Square.
A perfect square?
Yeah, how would you find the square root of a perfect square if you didn't know?
It's very hard. Like you can start guessing, and eventually you'll get there.
Oh.
Yeah, you can guess. You can say, all right, 5 times 5, or add 5 times. So you can figure it out. It's just really hard. That's why, thankfully, we learned it. Okay, let me go over the first part real quickly here. Let me tell you this real quick for your homework. Go ahead and turn it to your workbook. Workbook page. Make sure I say the right thing.
Page 1.
Yeah, I guess it is page 1. Page 1. Let me just help you so you know what you're doing on that section.
So we can't find
You can write it, but I'm not collecting that. So if you want to write some things in it for whatever reason, that's yours. But you're turning in homework papers to me that I'm grading. Okay, listen carefully. Page 1. You can read that top box on your own. That'll help you, especially on the second part. The first part, for each number, lists all the terms that apply. So you see that bold type right underneath that gray box? The instructions for 1 through 18. Fraction, mixed number, integer, repeating decimal, terminating decimal, rational number, irrational number. Look at number 1. The number 36. Is that a fraction? Is 36 a fraction just the way it is? No. So you don't write fraction. Is it a mixed number the way it is? No. Is it an integer the way it is? Yes. So you would write integer just like they did. Number 2, is it a repeating decimal? No. The tricky part is it a terminating decimal?
Yes, if it ends at 0.
Yeah, you could easily just have put that point right after 6. It'd be 36.0. It's a terminating decimal. Is it a rational number? Can it be written as a fraction? It's rational. If it's rational, can it be irrational? No. So you don't put irrational. So that's why they put those 3. Yes, sir?
So basically every whole number would be terminating decimal?
Yes. Max just said it. He gave you the answer to some of these. All whole numbers, or integers, we could say, all integers are terminating decimals. Yes, that's correct. Okay, I'm just pointing out some just to help you out, because you might get confused later on. Look at number 12, the square root of 25. What is the square root of 25? 5. So is 5 a fraction? Nope. Is it a mixed number? Nope. Is it an integer? Okay, what's the next one? Is it a repeating decimal? Is it a terminating decimal? Yes. Is it a rational number? Yes. Is it irrational? No. Number 6. Man, I'm doing too much right now. Number 6. Is it a fraction?
No.
Is it a mixed number? Is it an integer? No, so far. Is it a repeating decimal? Ooh. Okay, I'm not going to answer that yet. I'll give you it in just a moment. Is it a terminating decimal? I don't know. Is it a rational number? Oh man, this is where I get. Okay, is it irrational? If you're trying to find the square root of a non-perfect square, automatically irrational number. It'll never repeat. It'll never terminate automatically. So that's all I would put on that one. Irrational number. That's it.
But
For non-perfect squares.
Can you go deeper than that if you wanted to?
As in?
Like finding the decimal point and like finding what it actually is.
Well, even if you did, it still wouldn't be terminating because it'll keep going. And it wouldn't be repeating because it doesn't have a pattern. So you still would find out it doesn't fit any other category, which is nice. Okay, your homework or assignment is, thank you, I almost forgot that. 2, oh wow, don't want to botch that. 2 to 36 even. Yeah, it seems like it's not too bad. And then number 39. That's pages 1 and 2. Yes. You have, right now you should already have or should be getting a blank sheet of paper. You're going to fold it up. You're going to do the answer just like you normally do. That paper gets turned into me tomorrow. I'm not collecting your workbook pages at all. You can write in that book. It's yours, but I'm not collecting it.